In lesson 3.1, we're going to be starting trigonometric properties. The first three properties we're going to discuss are reciprocal properties, quotient properties, and Pythagorean properties. Let's start with reciprocals. We know these already. So one of them that we know is that cosecant of theta equals 1 divided by sine of theta. So cosecant is the reciprocal of sine. We also know that secant of theta is 1 divided by the cosine. And we know cotangent of theta is 1 divided by the tangent. Now we're going to take those three properties and we're going to manipulate them to look like new properties, but really they're the same thing written in a different way. We're going to multiply sine over to the other side, and that would give us sine theta times cosecant theta equals 1. If I multiply cosine to the other side, I get cosine theta times secant theta equals 1. If I multiply tangent, I get tangent theta times cotangent theta equals 1. So that's your first set of properties. If you want to know where those come from, if you think about an angle in your circle, and if you connect it to the x-axis, then put your theta in the missing angle, we know that each ordered pair has a cosine value and a sine value. So cosine is the x-coordinate, so we could put cosine here. Sine is the y-coordinate, so we can put sine vertically. And we know that it's a unit circle, so it has a radius of 1 or a hypotenuse of 1. And if you look at this picture, you can create these. So cosecant, we know, is hypotenuse over opposite, and so that would be the 1 over the sine. Secant is hypotenuse over adjacent, so that'd be 1 over cosine. And cotangent is adjacent over opposite, and so that is cosine over sine, which is just tangent upside down. But actually, that gives us one of our properties down here, is that if I want cotangent, we just said adjacent over opposite, cosine over sine. Now we also knew this earlier when we were doing our times test and our unit circle. So we didn't need the graph to know that, but now we can look at the graph and see why cotangent is cosine over sine. So let's find tangent as well. So tangent is opposite over adjacent, so sine over cosine. Now one thing we're going to do, those are really the only two quotient properties, but what we're going to do is take the reciprocal properties and change these into cosecants and secants. So we're going to make another one for tangent, and we're going to make another property for cotangent. So when I look at tangent, let's write it down here. When I look at tangent, sine over cosine, I can see it like this. Sine over cosine, and split it. When I have 1 over cosine, that is secant, which we see at the top. This is equivalent to secant, so that's going to change into secant. When I see sine over 1, that is the same thing as cosecant, but upside down. So this changes to 1 over cosecant. And when you put those together, you would get secant on top over cosecant on bottom. So that's another version of tangent. So basically, sine on top gives us cosecant on bottom, and cosine on the bottom gives us secant on top. So the same would apply here. Sine on the bottom gives us cosecant on top, and cosine on top gives us secant on the bottom. Or you can just think of this property being flipped upside down, since it since cotangent is reciprocal of tangent. And then our last set of properties is your Pythagorean properties. So if we think about the unit circle again and make an angle and connect it to the x-axis, and we know that this is the cosine value and the sine value, and that the radius is 1. Instead of using SOHCAHTOA, we could think about Pythagorean theorem, since this is a right triangle. So we know a squared plus b squared equals c squared. And I'm going to choose my x to be my a, so that'd be cosine theta squared. And then I'm going to choose sine to be my b. And then the c would be 1. So if I fill out the Pythagorean theorem, I get this, which we can write as our first property. I'm just going to simplify the way it looks. So instead of cosine all squared, we can write that as cosine squared. Instead of sine all squared, we can write that as sine squared. And instead of 1 squared, you can just put 1. Now we're going to take that and we're going to change it into 2 new properties. We're going to create our next equation using this one. And we're going to divide everything by, let's do cosine first. So if I divide everything by cosine squared, then I'm going to get 3 separate fractions. So I'm going to get cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. Then we're going to reduce these. Cosine squared divided by cosine squared is 1. Sine over cosine, we just saw in the table above. Sine over cosine is tangent, but they're squared, so it's tangent squared. And 1 over cosine squared, we saw in the top table is 1 over cosine is secant. So, but it's squared, so you can change it into secant squared. So that's our next property. 1 plus tangent squared is secant squared. All right, we're going to do that again, only instead of dividing by cosine squared this time, let's divide by sine squared. So start with your original. And now we're going to divide it all by sine squared. So that would give me cosine squared over sine squared plus sine squared over sine squared equals 1 over sine squared. Reduce this, looking at our quotient properties, is cotangent, but it's squared, so cotangent squared. This makes 1. And this is a reciprocal property. 1 over sine is cosecant, but it's squared. So that's our third Pythagorean property. Cotangent squared plus 1 equals cosecant squared. So those are the 3 sets of properties. Now we're going to use those to do some proofs. In example 1, they're giving you sine times cotangent, and they want you to transform it into just a single cosine using the properties. So much like a geometry proof, we are going to kind of make a 2-column proof here where you put your statement and then you put your reason. So my first statement is we're starting with sine times cotangent. And then in the second column is your reason, and that was given to us. So that's how we're going to start. Now at the very end, we're going to end up having cosine as our concluding statement. That's what they want. We have to figure out how to get there. So the first thing I'm going to do is I'm going to change cotangent into its quotient property. So I'm going to change cotangent into its quotient property. So why am I doing that? Well, first of all, it's not squared. So I'm not going to use those cotangent squared, which means I've got, looking at my options, I've got cotangent here, I've got cotangent here, and then I've got a cotangent there. but I want cosine at the end. So I don't want this one, there's no cosine in it. I don't want this one, there's no cosine in it. So that's why I'm choosing cosine over sine. So I'm going to take cotangent and I'm going to substitute in cosine over sine instead. Now you go vertically. Every time you make a change, do it beneath the first statement. Don't go horizontally. So what I just did was I used a quotient property. Then we use some algebra. I have got sine over 1 times cosine over sine, and my sines cancel. So that leaves me with cosine, which is what we wanted. So that's our last statement. The reason is we canceled sine. Or you could say we simplified the fraction, or we reduced the fraction, however you want to word it, but we canceled sine, and that's how we got cosine. And that's the end of the proof. Let's look at example 2. All right, so here's example 2. We're going to make a 2-column proof. So we're going to start with sine x, secant x times cotangent x, and that is given to us. And now we're going to change the secant. And if we look at our reciprocal properties, secant is 1 over cosine. So I'm going to go ahead and substitute in 1 over cosine for that. And so I just used a reciprocal property. I'm going to say that. Now I'm going to change my cotangent. And I've got some options. I've got 1 over tangent. I also have cosine over sine. And I've got some cotangent squared. It's not squared, so I'm not going to use that. I don't want to use 1 over tangent because there aren't any tangents in the problem, and I don't want tangent at the end. I'm going to use this cosine over sine because that's what I've got so far in the problem, the sines and cosines. So I've got 1 over cosine, and then cotangent is cosine over sine. And that was a quotient property. Now I'm going to simplify. So I have cosines cancel, and I've got sines cancel. Everything cancels. You get 1, and that's what they wanted. And so here, just say what you did. We canceled sine and cosine. And that's example 2. Let's look at example 3. In example 3, we've got cosine squared minus sine squared, and they want us to transform it into 1 minus 2 sine squared. So we're going to start with our given. Then from there, we're going to figure out what am I going to do to get there. So I see that cosine goes away, becomes a 1 somehow. And I see sine squared, there's now going to be 2 of them, and I only have 1 right now. So I want to keep this one, since I need 2, and I want to get rid of cosine squared. So I look through and I see, where do I have cosine squareds? The only cosine I really see is right here, and it's squared. So what we would do is take this cosine squared plus sine squared equals 1 and solve for cosine squared. So let me do that on another sheet of paper real quick. This is my property. Cosine squared plus sine squared equals 1. But I want just a cosine squared. So I'm going to subtract sine squared to the other side. And that gives me cosine squared theta equals 1 minus sine squared theta. And this I'm going to substitute in for my cosine squared in the proof. So if I go over here, I'm going to take cosine squared and change it into 1 minus sine squared. And that was a Pythagorean property. And now you put these together and you get your 1 minus 2 sine squared. And we just collected like terms.